Unit 4, Structural Idealization, Problem 3. Determine the shear flow distribution for the given unsymmetrical section as shown in figure when it is subjected to 100 Newton load inclined at a 45 degree. So they asked us to find a shear flow for the given section, and they have given the load condition V. It is acting a incline to 45 degree, that is 100 Newton is acting inclined to 45 degree. So if I take a resultant resolve, I will get Vx equal to 100 cos 45 degree and Vy equal to 100 sin 45 degree, and we know cos 45 and sin 45 are same. It is like 1 by root 2. So when you simplify, when we input those value, we will get 70.71 Newton for Vx and same value for Vy is 70.71 Newton. Okay. So if our section is unsymmetric, not if, our section is unsymmetric and they have given two loads Vx and Vy, then our shear flow formula is minus Q equal to Vy into Iyy minus Vx into Ixy divided by Ixx into Iyy minus Ixy square into summation of A into Y. So this is for idealize the section. So we have to write A in summation of A into Y plus Vx into Ixx minus Vy into Ixy divided by Ixx into Iyy minus Ixy square into summation of area into x. So in this formula we need to identify the moment of inertia values Ixx, Iyy and Ixy. To identify this one, we need to know the neutral axis, that is x bar and y bar values. So we know x bar equal to summation of area into a distance from the reference plane into divided by summation of area. The same way y bar equal to summation of A into y divided by summation of A is a area. For x bar, first we have to consider a reference plane. So I will take it as a reference plane as from A to B. So this is my reference plane A to B. So A and B, if I want to consider A and B, so the area is 1 and it lies in the reference plane, so distance is 0. The same way B, it lies in the reference plane, the area is 1 into distance is 0. For C, the area is 0.5, the distance from the reference plane is 16. The same way for D. So I can write for the area of A, boom A is 1 and it lies in the reference plane, it will be 0, plus the area of boom B is 1 into the distance is 0, it lies in the reference plane. Then the area of C, it is 0.5. It is a 16 centimeter away from the reference line. The same way for D, it is 0.5. The distance is 16 divided by the area of boom A, area of boom B, area of boom C plus area of boom D. When you resolve this one, you will get 16 divided by 3. It will be 5.33 centimeter. It will come. So for y bar equal to the same way we will direct for a y bar. So for y bar, I will take my reference plane from B to C. I will take B to C. So the boom B and C lies in the reference plane. For if I want to consider for A, boom A, the area is 1 and the distance is 12 centimeter. Okay. So boom A, the area is 1, the distance is 12 centimeter, plus boom B, the area is 1, it lies in the reference plane, the distance is 0, plus boom C, it lies in the reference plane, so the area is 0.5, the distance is 0, plus boom D, the area is 0.5 and it is a 8 centimeter from the reference plane divided by the area, summation of all the areas, area of boom A plus area of boom B plus area of boom C and area of boom D. So you will get 16 divided by 3 equal to 5.33 centimeter you will get. So now we identified a neutral axis distance. So 5.33 from the reference plane. Okay. So we have taken the reference plane AB. So our neutral axis is a 5.33 centimeter away from our reference point. The same way for Y, we have taken the reference plane as a BC and our neutral axis is a 5.33 away from our reference point BC. So this is our neutral axis. Now we will calculate the moment of inertia Ixx equal to summation of area into h square. So h is nothing but the y bar minus y1. That is a distance from the neutral axis. So for boom A, so boom A, this is a boom A, the area is 1 and the distance is from this point to this point, that is 12 minus 5.33. This is the distance from the neutral axis to the point A. That is, area is 1 into 12 minus 5.33. And also you need to know that this is our neutral axis. This is our neutral axis, and this is our first quadrant, second quadrant, third quadrant, and the fourth quadrant. So whatever the distance you take in the first quadrant, it will be both positive x and y, and second quadrant x will be negative and y will be positive, and third quadrant both the x and y are negative, and here for fourth quadrant x will be positive and y will be negative. So it will be very useful when you are calculating a IXY. For IXX and IYY, so we have a square parameter. So whatever the notation you have, it will be positive. Okay. Plus for B, the area is 1. For B, the area is 1. The distance is 5.33. It will be 1 into 5.33 square, plus for C it is 0.5. The distance is minus 5.33 whole square. This is also minus 5.33 whole square. Plus for D, 0.5 into this distance, that is 8 minus 5.33, 8 minus 5.33 whole square. Okay, so when you simplify, you will get a IXX value is 90.667 centimeter power 4. This is our IXX. Similarly, IYY is summation of area into x square. So h will be x bar minus x dash. Okay. So if you consider point A, area is 1 centimeter and the distance is this one. So it is a 5.33 centimeter away from the neutral axis. So it will be IYY equal to, for a boom A, the area is 1 into the distance is 5.33, that is minus 5.33 whole square, plus for a boom B, it is 1 centimeter into minus 5.33 whole square. For a boom C, the area is 0.5. The total distance of boom C is 16 centimeter, and we will minus 5.33. We will get the distance from the neutral axis minus the whole square. Minus 5.33 into whole square. Sorry, I made a mistake. It is not 0.55. It is okay. For D, it is 0.5 into 16 minus 5.33 whole square. So when you solve this one, you will get the IY value 170.67 centimeter power 4. Similarly, for IXY, you will get IX is equal to summation of area into x dash y dash. Okay, so now for boom A, the area is 1. So x dash is this distance. x dash is this one, and y dash is this distance. So it will be, it lies in the second quadrant, that is the x value will be negative and y value will be positive. Okay, into x value negative minus 5.33, it's a distance y, it is 12 minus 5.33 plus, for b it is 1 into, b lies in the third quadrant, both the x and y will be negative, it will be minus 5.33 into minus 5.33 plus, for c the area is 0.5 into the distance is 16 minus 5.33 for x, for y it is a minus 5.33 as it is lies in the fourth quadrant, plus for d 0.5 is the area into, for x it is a 16 minus 5.33, for y it is a 8 minus 5.33. When you solve this one, you will get the ixy value minus 21.33 centimeter power 4. This is our ixy value. So we have identified all the moment of inertia value. Now we are going to substitute all this value in the shear flow formula. So it will be minus q equal to, so first Vy value 70.71 into Iyy is 170.66 or 67 minus 70.71 into minus ixy value minus 21.33 divided by ixy 90.66 into 170.66 minus into minus 21.33 whole square to summation of a into y. Okay, for second term is plus Vx value 70.71 into Ixx 90.66 minus Vy value 70.71 into Ixy into minus 21.33 divided by Ixx 90.66 into 170.66 minus into, so minus Ixy minus 21.33 in power of 2 into summation of a into x. On resolving this, you will get equation minus q equal to 0.904 into summation of a into y plus 0.527 into summation of a x. Okay, now we have framed the equation for a shear flow. Now we will calculate the flow for each section, so A to B B to C and C to D. For now, section AB. Section AB, the area is, the starting area is like the section AB, the area of A is 1 centimeter square, and X is equal to minus 5.33. It's in the second quadrant. The value of X from A is minus 5.33, and the value of Y is 12 minus 5.33, that is 6.67 centimeter. So Y value will be positive. So minus Q AB equal to 0.904 into area is 1 centimeter, and the value of Y is 6.67 plus 0.527 into the area 1 into the value of X is minus 5.33. So if you resolving, we will get QAB equal to minus 3.22 Newton per centimeter. So this is our QAB. Similarly, for QBC, minus QBC equal to QAB plus Q. So the Q So we already calculated the QAB value. So now we have to calculate the Q for section BC. So section BC, A equal to 1 centimeter, the area 1 centimeter square, and X equal to minus 5.33. So it is in third quadrant, so both the X and Y will be in minus. Y equal to minus 5.33 centimeter. So we substitute the equation, that will be minus QBC, QAB, I will write it like this, QAB plus 0.904 into summation of into the area 1 into minus 5.33 plus 0.527 into the area 1 into the value of X minus 5.33. On resolving this one, you will get QBC equal to minus 10.85 Newton per centimeter. Similarly, for section CD, for section CD, the area A equal to, area is 0.5, okay, X equal to 10.67 and Y equal to 5.33. So it lies in the fourth quadrant, so the Y value will be minus. So the Y value will be minus 5.33. Okay, so minus QD minus QCD equal to QBC plus Q. The Q is 0.904 into the area 0.5 into y distance, that is minus 5.33 plus 0.527 into the area. The area is 0.5 into the x distance is 10.67. Okay, so you resolve. QCD equal to minus 11.25 Newton per centimeter, you will get. Okay, so we have identified the shear flow distribution for the given problem. Thank you.